Something very quickly. Some of you just asked me about the like keyword in iPhone. Okay, I'll talk about it very quickly to give you some idea. Although you don't need it, but you might need it in future purpose for your project or labs. Okay, so how do you use the keyword like? Okay, there's a keyword called like in the language for iPhone. It goes like this. Let's say we have a class called bank. Let's say we have a class called bank. And then let's say we have an attribute called accounts. Okay? And then it's simply of type array of account. Okay? Let's assume account is a known class to us. Now, let me give you the simplest example. Let's say you simply want to call, define a command for a constructor. Okay? Let's say we say make over here. Or you can say make from array, doesn't matter. Let's say make. And then I'm going to tell you the one that without using the like. I can say new accounts. And then the type should be the same as the accounts over here. Agree? Okay, so I would say array of accounts. Array of accounts over here. Okay, and then of course you can do all the relevant precondition, implementation, postcondition. Okay, this is absolutely fine. However, there is something called AnchorType. Okay, I'll write it down. It's called AnchorType. You know the word anchor, right? It simply means to mirror something. Okay? If something already exists, you can simply just refer to it without having to write it out again. For example, you can see we already declared this account over here, which is global to all the class, the entire class. And now we already declared the accounts of this particular type. So now, rather than repeating this particular declaration over here, which is okay, but you can save some time by saying it's going to be of the type just like the accounts. So I can say like, which is a keyword, and then accounts over here. So basically, as long as this particular variable is known to the scope, then you can use it. I would say typically, you will put maybe some attribute name after the like. Okay? I forgot if I got any instance of the anchor type in lab 1, but I didn't require you to do it. Okay? But just some convenience. Okay? Let me just say one more thing. Okay? So the reason for anchor type is not just for convenience. That's only a secondary issue. The first issue, again, is about single choice principle. I'll mention this word again, even though I haven't really introduced that yet. Okay? It's called single choice principle. Let's imagine this, okay? Let's imagine that if we have to repeat this type over here, that's the same as the account for many times in your class declaration. Maybe you have another feature called make from array. You have another feature called maybe change from array, something like that. So that you have to repeat this particular spelling for so many times, let's say. Later in your developments, if you decide the following, I decide rather than having an array of accounts, I want to have simply just, let's say, linked list. I'll just say LL for linked list. I simply want to say linked list of accounts. So now, let's say, if we did not use the anchor type, then how many times do you have to change that particular type from array into linked list, depending on how many times you have used it? Agree? So now, if you use anchor type, you don't have to change anything. Guys, do you see what I mean? Should I make it a little bit more concrete for you? Okay, everybody look puzzled. I better make it more concrete for you. Okay. All right, let's start from the very scratch. Since I've talked about it, I want to talk about it properly. Okay. Okay. So now let me make it. Okay. Let me clean this. Let's say this. Accounts again is of type array of accounts. Okay. Let's start from the beginning. And then new accounts is also, I'm going to just repeat it. Okay, imagine that you're going to type it twice. Okay, let me define just another feature. Okay, let's say change. How about just add? That will do. Remember in Java array list, you can add a list to a list. Let's do something similar. You can say add accounts. In which case, I would say ACCS, just choose a different name. Okay? And then this should be, I just want to append this particular array of accounts into it, let's say. Okay, so I got two features, but I can generalize it to, you may have a number of features where you're trying to repeat the same declaration for many times. Okay, so now notice this. What we have got, we got this one here, declare once, got this one, the same declaration twice, and also this one 3 times. Okay? So now let's say for some reason you decided that you didn't want to have array anymore. You simply just want to have a linked list, let's say. Okay? Basically, whenever you want to change type, it can be any type you like. Now, if I simply modify this guy over here to be linked list of accounts. So now, I cannot add array directly to the end of the linked list, can I? I cannot. So what I have done before to mirror the array is now all invalid. So now what should I do manually? I should change this to be linked list. I should change this also to be linked list, right? I got to do the manual change for as many times as I need. Okay, so now what would be the advantage for AnchorType? Okay, so now, okay, you pretty much get the idea. Okay, that's what you should usually do without the AnchorType. Let's go back to where we were in the beginning. Let's say rather than having this guy over here, oh, sorry, this one should be there. But now for every place where we intend to have the same type, we simply say like. Okay, so I will simply say like accounts, which means whatever the current type is for accounts, I'm just going to follow that. Okay, and then I have like accounts. So now, question for you. Let's say we do the same change later in your developments. If I simply change this to linked list, now, how many places do I need to change? None, right? Because I already done the change. Everything else will just be anchored to it, right? That's called AnchorType. So as I said, AnchorType is not just for syntactic convenience. That's only a secondary issue. The first issue, let me finish that. The first issue will be, whenever you want to make a change, there's only a single place you have to make the change. So that's so-called single choice principle. So that's something we'll see over and over again in the course. But AnchorType is just one instance of that for single choice principle. Okay, question?
So it's kind of like creating a type definition?
You can think about creating a type definition. You can think of that, yes. However, we are not really trying to define array of account to be a type name. We're just saying
Same idea.
it's same idea. Yeah, you just want to define something in one single place and reuse it. Okay.
It doesn't have to do with this, but can you talk about null? Because I used void and void gave me a warning.
You talk about, okay, if that's kind of specific to your lab 1, I'll rather talk about it after class or approach me in the lab tomorrow. That'll be easier. Okay. I'm happy to answer just to be better context.
I just
Okay.
want to know what's the substitute for null.
Basically, briefly speaking, so there's no null in IFO, just a different keyword. The idea is the same, which means the address you store is meaningless, right? So it's in Java it's called null, in IFO it's called void. Okay, that's the difference. Yeah, but don't use null, of course, in IFO. Okay, that's just one of you asked, but I'll just answer that. Okay, that's just it's an interesting language feature you can see, which doesn't exist in every language. So you just want to see. Later on, if you want to take some language design for programming languages, that will be some issue you can think about. Okay, that's the first one. And now I want to go back to where we were. So today, the main goal is to, number one, I want to go over the 3 kinds of copies that we talked about last time. We got reference copy, shallow copy, and deep copy. I want to do a simple example first, and then we'll move on to talk about systematically how all expressions should be used. And number 3, we want to see a complete example for how to write across all keyword and twin or deep twin all together. Okay, that's the goal. If you got any time left, I'll talk about bound diagram. But you got the slides already. You can go over them. Okay, I'll try to see if I can do that. Otherwise, I can do a little bit tomorrow in the lab. Okay, so now let's go a little bit slides here. Okay, that's where we stopped last time. Okay, basically we want to have, again, let me remind you a little bit to set the context. Let's assume we have 2 variables here. We got imp Also, we got old imp. We got two separate variables. There's a reason for me to set this up like this way. So that will help you understand how the old keyword will be implemented in iPhone. Okay. Okay, so let's say we have an empty array, and they will simply append to the end Alan followed by Mark followed by Tom. Okay, so now why am I setting up this way? This is what you keep in mind. Okay, the idea would be, number one, before we try to make a change to imp, imagine that imp represents the current implementation. Before we try to make a change to it, we first of all try to copy the current imp into the old imp. I put the copy in quote. That means we can either follow a reference copy or a shallow copy or a deep copy, right? We don't know which one should be suitable yet. After we have done the change to the imp, now we want to know the following. Are we able to see the change on the imp between the old imp and imp? Basically, there are two versions of the imp over here. We want to know whether the copy that we did initially is going to help us observe the change on the imp. That's basically the issue. Okay, that's also the general issue about how you can check postcondition. That's kind of the setup. But these 3 points, hopefully, once we see all the versions for this example, it will make more sense. But I just want to mention that first. Okay. Just imagine that we're going to do something to imp, and then we want to see if that can be reflected somehow. Okay, let's see what we have over here. Okay, so this is how we start with. So we have an array of strings. So we got Alan, we got Mark, we got Tom. And how should we copy oimp? We don't know yet. Let's go over all the possibilities. Okay, version number 1. Let me show the code a little bit because all the versions, the code structure is very similar. Okay, for the very first one, let me go through line by line with you, and then we'll ask you some questions. Okay, so now if I got this one here, and then I say result is, oh, actually, the first line, let's look at that. Is this, what kind of copy is this? Reference copy, thank you. So now we are trying to copy the address from imp to old imp, only a reference copy. Now, very simple check. True or false? True, very good. That's easy. And then let's try to do this, okay? Before I try to visualize it, let's try to think about it. I'm trying to say now, I'm going to change the reference at position 2. Remember, indices start with 1, so the middle position. Rather than pointing to, remember it's Alan, followed by Mark, followed by Tom. Rather than pointing to Mark, it's now going to point to Jim, okay? And now I'm going to run a cross over here. And the across basically is to think about line number 3 is the change we are trying to make on the imp. And somehow in line number 1, we already make a copy of the old version of the imp. Now, if we try to compare the old and new versions together, are we able to see the changes? Okay, I heard yes, I heard no. First of all, let's understand what this loop is trying to do. Basically, we are trying to, you can assume that we simply don't modify the length of the array to make it simple. Okay, we're going over the from 1 until the count of the new array, the current array, and then we want to see if the old version and the new version is correspondingly, position-wise equivalent. So the tilde simply compare the contents of the string. Okay. Now, do you think this is going to give you, from line number 5 to line number 7, it's going to give me a Boolean? True or false? Okay, it seems like majority say true, but let's verify that. Okay. It turns out to be true. Let's see why quickly. Okay, it's going to be the same setup for all the other versions. Okay, so now let me change to here. It's very easy to see. So now, as soon as before I try to do the change, I would say old imp. It's now pointing to the same position over here. So now they're both pointing to the same place, the same. Okay, so the change I'm trying to make in line number 3. Sorry, let me make a, okay. This is the change I'm trying to make. So now imp at position 2, rather than pointing to Mark, it's now pointing to, let me say Jim. I'll just put a string, like objects over here. So now, if I try to run this across loop, should that be true or false? Let me ask you again. think about the iterations, okay? For how many iterations, first of all, in total? 3, right? For the very first iteration, j will simply just be 1. And then we are basically doing imp at position 1 is equal to old imp at position 1. This is not the intended place to be modified, right? So now if we do that, would that be this true or false? True, it's trivial because if you go imp over here, it's referring to this slot. Old imp is also referred to the same slot. In fact, they are just the same. So even if you change this to just this, rather than just tell that if you even if you say this, it's also going to be true. Okay, just make a note. Are we okay so far for the first iteration? Now let's go for the second iteration. Second iteration is going to be looking at the slot that we try to change. Let's say now j is now going to be, let me use green. J is now going to be 2. So that means we're comparing imp at position 2, let's say tilde, let me still use tilde, and old imp at position 2. Now, can we see the change? Would that be true or false? It'll be true, because again, at position 2, we are just referring to this particular object called Jim. Doesn't matter if you follow the old imp or imp, doesn't matter. So now, this tells us true. In some way, that's not very good, because we did make a change before. So we wouldn't expect the two versions to be the same. We expect to see false. Okay? Let me write it down over here. So now true over here, not good, because we expect to see the two versions being different. Okay? Everybody follow this idea? Okay, so that's the first version I want to show you. Basically, that means if you want to compare the old version and the new version, the way you make a copy of the old version better not be a reference copy. That's the main lesson here. But what should be the copy then? Well, I can tell you the conclusion right away. If you simply do deep copy, always, you will never run into an issue. You can always see the changes. That's a conclusion. However, that's not how I would expect you to understand the issue. Sometimes, depending on what kind of change you are trying to make, maybe making a shallow copy would just be sufficient enough to see the change. That's why I want to show you the whole story. Okay? So in the exam, most likely I would just ask you, given this particular setup for the objects, for example, like this, would a shallow copy be enough, or you have to go for a deep copy? That's kind of the question I will ask you. Okay? Let's see. Let's see the whole story. But reference copy is just a warm-up. Okay? Let's now see the second version over there. Okay? But you can see the much nicer diagram on your slides, right? But I thought drawing on the fly might help you a little bit. Now, the second version over here, now we are saying that before we try to make a change to imp, we are trying to make a shallow copy of it and put it into old imp. That's what we're doing, right? That's the only difference. Everything else is the same. Okay? So now, first of all, what would that be? Line number 2. Well, so that kind of relates to your understanding about the shallow copy, right? For the shallow copy, we do create another new object at the first level. But from the second level, they will be aliasing, right? That's what we said last time. Okay, I'm going to assume you're okay with that. Otherwise, speak to me. Okay, that will be false. That's no problem. But now, let's say we try to do the same change. We simply reassign the second position in the array into Jim, the same change. But now the only difference in line number 1, the way we back up the old version is by using a shallow copy. So now a question for you, running the same across as before, just the same, do we expect to see true or false? Okay, it's kind of a mixed responses, right? That's okay. I would say for this particular kind of change, let's pay attention to the kind of change you're making. If you look at line number 3 more carefully, we are trying to reassign the references rather than changing whatever object that's being pointed to. There's a difference there. You're going to see. Okay, let's go back. Before I show you the answer, I would like to go to the diagram over here. That's the second version that we just saw, right? So now you can see we are trying to do a implementation twin. So that means old imp right now, maybe let me just use blue. So that'll be, I can reserve the red for later. So now let's say we have old imp over here. So now it is going to point to a new object, which means array, right? So array of string. Okay, I just abbreviate that. And then that one there should have 3 slots. First of all, agree? So now, should we make any new objects? We shouldn't, because there's a twin, there's a shallow copy, right? So that means, I'll try. First of all, this is going to point to the first one, and this is going to point to the second one, and this is going to point to the third one. Okay, that means just one example. If you try to say old imp at position 1 equals imp at position 1, would that be true or false? True. Okay, just to verify that. Okay. On the other hand, if you simply try to compare their references, it will simply just give you false. Okay, good. So now let's try to run this across loop and see how we can do it. Okay, I'll just do one for you. Okay. So now let's say, again, we're going to run 3 iterations. What about the first iteration? For the very first iteration, it's going to be position 1. Okay, so we are doing implementation at position 1, tilde, old implementation at position 1. Well, true, right? We just said that. Okay, very good. Okay, let's go one more. Okay, let's go to the position that we intend to change. Are we able to see the changes? According to the diagram, can you see the change? Let's do the change. I forgot to do the change, sorry. Line number 3, I forgot. Okay, line number 3, I'm saying that implementation is pointing to this particular array, and now rather than pointing to this particular string, it is now going to point to Jim. Okay, something I'm supposed to do. Okay, so now let's go to the second iteration. The second iteration, J is going to be 2. So we are basically doing implementation at position 2, tilde, old imp at position 2. Now, would that be true or false? Okay, let's try. The answer is it should be false. However, let's see why. Okay, so now let me just try to highlight it. So now, first of all, what's old imp at position 1? Old imp is over here. Position 1 is now pointing to this particular, position 2, beg your pardon. Position 2 is over here, so it's now pointing to this particular object for mark. Okay, and now what about another one? Another one is imp1 over here. So now imp at position 1 is now has been redirecting to Jim. So these are 2 different objects, green versus orange, so they're different. So that means somehow shallow copy could be useful to see the changes if the change is only about reassigning the references. However, there will be some limitation to shallow copy. That's exactly what I'm going to show. Anybody can predict what kind of change that I try to do on imp would not be visible somehow if I do a shallow copy only. Yeah, basically if I do anything that's beyond the first level, then I wouldn't be able to see the change. Okay, let's see that. Okay, we're just going with this gradually. Okay, so now let me just go to that version directly. Okay, the code structure is just the same. Okay, so now let's see this. So now we are talking about version number 3. So now it's version number 3. Okay, so now we are still doing a shallow copy still, but now the difference is, in line number 3, the kind of change we're doing is, rather than reassigning imp at position 2, we simply try to do something with the objects that's being pointed to. Okay, it's a very different change, right? You can see in the previous version, we are trying to reassign. In this version, we are trying to call some command, which means we're trying to change the object itself. Okay, understood the changes? So now, of course, if you simply try to check for line number 2, it will just be false. That's not a problem, because for shallow copy, we're making a new object. Now, the question really is, if we are trying to do this guy here, right, the same check, Should it be true or false? Well, if you say that's true, that means shallow copy is not good. Shallow copy is not good enough for us to see such change, right? That's what you claim. But before I'm convinced, let's draw together, okay? So now let's give it a try. Okay, again, the way I draw that will be very similar. I'll say old imp, again, is pointing to the array objects over here, array of string with 3 elements here. The first one is pointing to here, and the second one is pointing to here, and the third one is pointing to here. Okay, that's a setup. So now, if I try to change, let's say in permutation 2, first of all, in permutation 2 is over here, and then I want to append, let's say star, 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 to whatever string that's being pointed to. Okay, it's pointing to this particular string, and then I'm going to say rather than mark, it's going to be now mark, followed by star, star, star. No new object has been made in this case, but I'm just changing that particular object at the second level. Okay, so now let's go directly to the second iteration. The first iteration will just be the same as before. Okay, let's go to the second iteration. Let me use blue be okay. So now in the second iteration, j would just be 2. Okay, and now if I say imp at position 2, the same as old imp at position 2. Should that be true or false? Are they pointing to the same objects in this case? They are. So of course, tell that it's going to be true. It's going to be true. Let me just annotate it so you're convinced. So now you can see that over here, imp2 is really pointing to this particular object here, which has mark star, star, star. And then if you try to do something similar, what about old imp2? Old imp at position 2 is now also pointing to the same objects. Of course, also has mark star, star, star. Guys, any question? Basically, so far we have seen 3 cases. Case number 1, if you're trying to make a reference copy, it doesn't matter what kind of changes you're making. You just cannot see it because aliasing. If you do a shallow copy, if the change is beyond the first level, then you cannot see it. If it's only about assigning the references at the first level, then you can see it. Okay, that's the 3 cases we have seen. So now, what are okay? Question first.
Primitive type shallow copy would always be up, right?
That's a good question. So the question was for primitive types like an integer, Boolean, or basically like a int, bool, and double back in Java, would you have to do a deep copy? The answer is you don't have to for primitive types. Things usually get tricky when you get to reference type. Okay, that's true. Don't forget, string is a reference type. So if you actually got string, you better be careful. Okay, yes? First level simply means, so if you look at the array over here, okay, what I meant by level was like this. Let's say the array is, oh, okay, sorry, I was looking at that screen. So A is pointing to, let's say, this particular object, let's say, just object, let's say bank. And the bank is simply having these attributes. Let's say maybe attribute A, attribute B, attribute C, right? And this might point to something else, can be as complicated as it might be, right? And this might also point to something else, okay? What's the first level? First level simply refer to, first of all, the object itself. And also the reference for all the attributes at the first level. That's what it means. So that's the green is the first level. The second level is basically everything that's referred further. Okay? But as far as the 3 kinds of copies concerned, you only have to know what's really the first level and what's beyond the first level. You don't have to worry about, oh, what's really happening in the 4th level. You don't have to, right? Either first or beyond the first. Okay, very good. So now let's go back to this. Okay, let's now see what's our remaining option. Deep copy, right? So now we want to see if deep copy is always good. So now for the deep copy, I'm going to run 2 changes quickly. I'm going to see, first of all, what if I try to reassign the reference at the first level? And number two, I'm trying to change something beyond the first level. Will I be able to see the changes? You want to take a guess? Should you be able to? You should be able to, otherwise we have no other copying mechanism, right? That means the whole thing wouldn't work. Yes, it's going to be fine. Let's see. So now the second last version over here. So we got deep twin. Okay, that's not good. So now we have deep twin. Okay, and now let's try the easy one. Oh, very quick check. What should be this? Line number 2. False, right? Just making a new object, no problem. Okay. So now let's take a guess. Before you take a guess, well, you can make an educational guess, of course. So now line number 3. I'm simply trying to reassign the reference at the first level, which was already okay, which was already visible by the shallow copy. Would it be the same for deep copy? Can you see it? Think about it. So now, basically, I'm trying to reassign the reference, and now will I be able to see the difference between the old and the new? I should be able to, right? Let's verify that. So now, if I have that, so if you say yes, you're thinking that this should return false, right? Let's put a question mark here. Let's verify that. First of all, let's make a deep copy. So I'm going to say old imp. Old imp is now going to be, first of all, let's create a new array object first. It's going to be an array of string with 3 slots over here. And now question is, should I make any reference copy here beyond the first level? Oh, should I? No, right? I should make a deep copy, right? Okay. So now what I should do is, the first one is simply going to point to a string over here, and I'll just put Alan here. And then the second one is going to be a deep copy of this, and that one there is going to be a string for Mark. And the third one is going to be a deep copy of Tom, and that's going to be string and Tom. That's a deep copy. You can see it's completely separate. Now, question for you. If we try to run this across, right? Again, let's pay attention to the second iteration, okay? If we try to do the second iteration, before I do the second iteration, let's do the changes first. Now, the change at line number 3, what am I changing really? Am I changing the original imp, or am I changing something else? Okay, let's see. Imp is exactly here. At position 2 is referring to this particular slot. Rather than pointing to over here, it's now going to point to Jim. Okay, you can see apparently Mark for the deep copy is still here. It's not unaffected. That's the value for deep copy because we can see the changes. Okay, now it should be quite easy. If you run this across, it should be false. Okay, but let's see. Let's say just take a second iteration, for example. For the second iteration, which is the slot we intend to change, imp at position 2, the same as old imp at position 2. Should that be true or false? That'll be false, right? Because now, again, let's try. If you try imp at position 2, imp at position 2 is now pointing to this particular objects. Okay? On the other hand, if you try old imp at position 2, old imp at position 2 is referring to this guy here. So they are completely different objects. One is Mark, the other one is Jim. So you can easily see the changes. And this change was also visible by the shallow copy, but for a slightly different reason. Okay, so now what's left? We want to see if the deep copy can achieve what cannot be achieved by the shallow copy. That's what we want to see. Final version. Okay, the final version is we are still trying to make a deep copy over here, deep twin. Okay, we're still doing it. And now the changes we are trying to make is we're trying to go to position 2 and then try to append star, star, star. And we learned before, shallow copy is not sufficient to see this kind of a beyond the first level change. Right? That's all we saw. Let's try to draw the diagram. Okay? Again, I'm going to, how do I draw the deep twin? To complete separate. Bear with me. So imp is pointing to an array of string, 3 slots. Each one of them is going to point to separate string. Alan, and this will be a new string, Mark, and then this will be string Tom. All right. So now let's see this. How do I implement this particular change? When I say imp at position 2 dot append star star star. Well, imp is over here. Position 2 is here. So I'm trying to change this particular object here. So now it's going to be Mark followed by star star star. Now, can you see the value for deep copy here? Because now you can see very clearly that this is at position 2 of the current array. This is at position 2 of the old array. Right? Apparently, I just made a slight typo over here. This guy here should be old imp. Okay? That's a slight typo I made. So now you can see that these two green objects over here, this guy here and this guy here, they're simply different objects. So now we can do the suitable comparison. Okay? So now when you try to run this across loop, would that be true or false? False. Okay? That's good because now we can definitely see the changes. Especially if you try to do for the second iteration when j is equal to 2. So you say imp at position 2, the same as old imp at position 2. You can quite easily see that. One is referring to this particular object, and one is referring to this one. And you can definitely see the change. So they are not equal. Any question? You'll definitely see the value very soon, because this will really build your understanding to understand all keyword in just a moment. Yes?
You said that on the exam you'll tell us to mention whether we should use a shallow copy.
Okay, so in the exam, there are different kinds of questions I can ask you. I'll give you some example. It could be that I simply say, now please write the contracts for this particular feature, in which case it would be always safe if you simply say deep copy. Okay, that's, you can always say that. But in the exam, we wouldn't be so picky because of written exam. But in the lab test, you got to be careful. When you have to use deep twin, you use deep twin, right? The second kind of question is more important. I might show you a contract right away where I use deep twin. And then I will ask you the following question. Is it really necessary to use deep twin over here? Would it work if I change that to twin? Would it work if I change that to just reference copy? If your answer is yes or no, justify. Yeah, actually you will see some question like that at the end and for the slide. I'll give you a little bit example. Yes. Yeah. You mean is there a situation where reference copy might be useful? When you do, no. I would say reference copy, not really. So that's actually something you will see. Whenever you're trying to use the old keyword, you got to be careful. If you only telling IFO at the runtime to do only a reference copy for the old version, it's not going to be useful at all. Yeah, but that's what people write sometimes by mistake. Yeah. Okay, so, yes.
So I heard you say that changes in, like when you use shallow copy and deep copy, you say you say at the end that changes are detected, changes are not detected. What is the motivation for detecting these changes? Is it just ensure that?
Oh, I see. So basically, as far as these examples are concerned, we only worry about when you make a change to imp, is it possible to see that change when you compare that against the old imp? That's all we are asking. But now we're going to move one step further, which I'm going to explain. Okay? So now, let's think just a little bit more to connect to the actual decide by contract we're going to do. Thinking this way, the old imp is basically some mechanism that IFO is going to do for you implicitly, automatically. You never have to write an old imp yourself. Okay? But what do you have to write in IFO? You actually have to use the old keyword. And now, depending on how you exactly write the old keyword, is going to trigger different kinds of copies. Okay, I know it sounds a little bit weird, right? But I'm going to explain to you, that's why. Okay, I'm just trying to make a connection here. This example we have just went through, I've gone through, is just to reaffirm your understanding about shallow copy, reference copy, and deep copy. And now we're going to see exactly how the old keyword is going to be interpreted by the IFO compiler, and see exactly how they actually store the old versions of your attributes. And you will see exactly how this can be connected. You don't see that just yet, but you will see. Okay. Any other question about this example specifically? Okay, so now everybody's warm up, right? About reference copy, shallow copy, and deep copy, right? Good.
So, if you use deep copy in the lab, or you could use shallow copy, or which one?
No, actually, I would say let's talk about just programming, right? When you are trying to program, you're trying to do programming, if you're trying to use the deep twin where shallow copy will just be enough, that would be okay, right? Not the other way around. But I would say just in the exam, if I really want to see your understanding about using just the minimum, then you might get into trouble. That's why I'm trying to show you the whole lecture on this. Okay, good. Make sense? Good. Different concern, right? Okay, let's go back to the slides. Okay, we have done with this set of examples. So what I would do is, okay, everything has been done. Okay, I'm not skipping anything. Okay, let's talk about just one slide. How are the contracts checked at runtime? Okay, rather than showing, let me show you a little bit of bullet points here. Okay, I'll go through that quickly, and then I'll give you an iPad illustration. All the contract, but first of all, should be Boolean expressions, right? Anything you put under require, under ensure, under invariance must be Boolean. For example, a very common mistake I have seen, right? If you try to do this, if I have require over here, the same applies to ensure and invariance. If I say x equals y, would it compile? Oh yeah. So that's the number one common mistake. Okay? Basically, what you're doing over here, you're trying to do an assignment, which does not return anything. It simply does the changes without returning anything. However, when you do require, it is expecting some Boolean value. Okay, watch for that. Okay, expecting Boolean expression. Okay, that's just want to point it out quickly. Okay, so after this, let's talk about something else. Okay, and then, so now just go over this point quickly. Every time before a particular feature call, okay, every time, we call the current state a pre-state, right? Pre-state versus post-state, right? And then we want to evaluate the precondition, okay? Evaluating precondition is very easy. There's no O keyword. Just evaluate whatever the input value is and whatever the attribute value is. For example, balance, right? Maybe the current balance should be larger than 0, okay? And now, this is the most complicated part when you talk about postcondition, right? Because usually postcondition, to write it, you have to say, I have the values in the old version, I have the values in the new version. How are they related to each other? That's a tricky part. So I would say what you have to do is to watch for all the possible combinations for O expression, which is something I want to teach you about, okay? Okay, is this even feasible? Okay, don't worry, I'm going to illustrate that in detail. I want to show you all the possible O keyword you can use. Don't worry about what that really means. I want to show you all the 7 possible ways you can write. Question?
Before we move on to postcondition, I just want to confirm, when you have a constructor, you don't write a precondition for a constructor because you don't understand beyond what's initialized, right?
For constructor, yeah, I know what you're trying to ask. For the constructors, you may want to write preconditions sometimes because you want to make sure, what if, let's say this, if you're trying to create a new bank account, you'll take some initial balance. In this case, the initial balance the user gives to you may be negative. In which case, if you simply take it without any condition, in that case, you can create invalid bank objects. So I would say whether to create a precondition for your constructor or not depends.
But that's exactly where there's a class invariant, right? As opposed to the explicit require statement in the constructor.
So we'll revisit this point a little bit later. The idea is, in order for me not to really create invalid objects, I don't really want to see the invariant violation happen. How can I prevent it from happening? Well, put the corresponding precondition to prevent it. Okay, good. Okay, let's go back to this. So now, just look at the different syntax, right? Let's just distinguish between syntax, and then we talk about what they really mean. The first one, I simply write I'm talking about postcondition only, right? You cannot use the O keyword in either require or in invariance. We're only talking about postcondition. Now I say old account. Oh, let's assume the following. We have a bank class in which we have an array attributes called accounts. Let's assume that. Okay. So let's say in the postcondition for my bank class, I might write old accounts at position I.id. Okay. I might say, don't worry about what's set in the second column. Don't worry about it. You can ignore that for now. Okay. The second way, I can say old accounts I being bracketed .id. Can you imagine these two things mean something very different? Okay. The third possibility, I can say old accounts at position I.twin being parenthesized .id. I can say old accounts parenthesized at position I.id. I can say old accounts.twin parenthesized at position I.id. I can say old current parenthesized accounts at position I.id. I can also say old current.twin parenthesized the accounts at position I.id. There are actually three more possibilities I didn't mention, deep twin, but let's not bother. You can generalize the story. The reason I'm showing you all these first is you have to be very careful when you're trying to use the old keyword. But don't worry, for lab 1, things cannot go terribly wrong. Okay? But it's good to know it now. Okay? So now, all 7 of them mean something different. Okay? Because you're going to spell the syntax differently, all of them are syntactically correct. Nothing is wrong. However, the way you write it is going to trigger the IFA runtime to store the old version differently by using reference copy, shallow copy, or later on maybe even deep copy. It depends. Okay, let's see. Let's now move to iPad. Before maybe let me talk about the old expression first. Oh, maybe this one will be fine. Okay, let's talk about this first, and then we'll move on to all the 7 I just talked about, right? So now, in general, if you have some precondition here, which is not our concern for now, you have some implementation, and now let's say somewhere under your ensure, okay, ensure clause, that's a postcondition, you simply got some old expression, and now what can be the possible ways of writing old expression? For example, the 7 ways I just showed you, right, differently. So now let's see what's going to be checked at the runtime. So as soon as you say, I want to call this particular feature f, let's say I want to call that. First of all, we'll check the precondition. And then eventually, well, let me skip a little bit. Of course, at some point, you're going to execute the implementation of f. And then after that, you will try to check the postcondition of f. However, in order to make this work, certain values have to be stored before you try to change the current implementation. That's pretty much like we try to say old imp is assigned to something before we try to modify imp. That's exactly the same pattern over here. So now you can notice that the most important step is we want to make sure before you try to execute the implementation of your f, like before we try to apply the change to imp, what we do is we try to, I call it cache, which means store temporarily. We try to store the expression value over here, conceptually. But now we want to see exactly what will be stored. That's the issue. Okay? Conceptually, are we okay? Okay? I'm just saying that this particular step is completely hidden from you. This particular step is done by IFO automatically to make the old expression work. However, you as a programmer or designer, your responsibility is to make sure whatever old expression you put over here is going to trigger the correct copy, the correct behavior. That's your responsibility. Good. Let's now see the different stuff over here, right? I got 7 of them. Okay, I'll try to see if I can go over a few, to see if that makes sense. Okay, so now we got all the 7 over here. I think okay, I got a different color. Okay, the first one we're gonna see. Let's see this guy here. Oh, sorry. The first one is exactly over here. Okay, the first one is old accounts at position I.id. Basically, you can see that this is just a 1 unit over here, which is I want to get access to account at position I and then get ID. That's what I'm doing here, right? And then I'm saying that the old keyword applies to the whole expression. That means this particular expression will be stored or cached before I try to make a change to the bank. Can everybody see it? Okay. So now, what are we going to do over here? So now, imagine that this, okay, so now we want to see this is the bank we're talking about, which has an array of accounts, right? And now let's say we intend to modify position I. Let's say that's a position I. And then, which is pointing to account over here. So now we want to see what will be stored before the feature implementation is executed for blue one. Okay, this one here. What are we copying really? What's one going to copy? What do we copy really? Do we copy the whole bank objects? Do we copy the account objects? Or do we copy just the ID? Just ID, right? Because this one here is referring to an integer. So 1 is really just going to be 23, just that. That's all we do, the old expression. So in your postcondition, for example, if you simply say old accounts at position I dot ID is equal to, let's say, accounts at position I dot ID, if that's your postcondition, okay? Now, if there wasn't any change, this postcondition will be satisfied, right? If there was a change, for example, if I change that from 23 to 46, should it trigger a postcondition violation? In this case, it will, right? Because now you're comparing 46 versus 23. Okay, I'll just give you some example, okay? Good, let me undo this. It will get better, don't worry. I know it's just starting to get a feel. So now for the second one, okay? The second one, tell me something. What expression will be applicable? What expression will be applied by the old keyword? You said deep copy. So where is the deep copy though? But how do you know it's a deep copy rather than shallow or reference? You don't. Okay, good. Actually, I forgot to mention something. That's good. Okay. There's something that's mentioned in the slide. I want to point it out quickly. So there's a single sentence over here. Please pay attention to it. Okay, I'll point to you. We say cache or store values via a single assignment. Okay, so now let me switch back and tell you what that really means. So now let's go back to this particular first example over here. Okay, so now we have the old keyword over here, and now we have this. Every time you're trying to store the value, IFA does something very easy. Okay, so now you simply say, let me just do this. Let me just erase this and do it again. So what you will do is it's going to say 1 is simply assigned. It was just a simple assignment, right? Whatever you have over here is going to be copied verbatim. And then it will simply say accounts at position I dot ID. And we know that in the pre-state, this is simply just 23. So that means 1 is simply just going to get a value of 23. Okay? So now, if you really want to trigger a shallow copy for the old version, what should you write in your postcondition? You should write twin. Yeah? But here there's no twin, so there's a reference copy only. Okay? So as far as the IFA compiler is concerned, they always do just assignments over here. That's all they do. Okay, let's keep just do a bit more. Now, back to the question. Number 2. So, Michael, right? Give it a try. Number 2. What are we trying to store?
We're trying to store the value of the array at index I, this reference of the value.
Oh, good. You say the value of the array at index I. So to be more precise, what's the value at index I? Is it some value or is it object or address? It's an address. Very good. Okay. Okay. Well, Michael said was exactly correct. So what we're doing here, let me write it down. For number 2, we're basically doing 2 is assigned to in the before states, right? Accounts at position I, and then the brackets is your friend in this case. You want to force the old expression to apply to certain things. And by the way, there's a common mistake you guys posted on the forum. I'm not sure you're either from section A or section E. I'll talk about it. It's related to it. So now I'm going to say, so brackets is exactly over here. So now I'm going to say just that. Okay, that's deep blue version. So now what would be 2 here? It's going to say accounts at position I is pointing to this particular object over here, right? So now that means number 2 is now also going to point to this particular account. That's what 2 is doing. Guys getting better? Okay. Okay, maybe I wouldn't want to waste too much of your time. You couldn't get the idea. Should we try just one more? 2 more, how about it? Let's try 2 more. Okay. Let me choose. Let's say we do another one. Let's do something that's with a twin. Okay, how about this? Which one? You mean, tell me the number. Good, I like that. Yeah, that's my plan anyway. Yeah. How about we do 6 and 7? Okay. You know what? Maybe 5 and 7. That'll be better. So now let's do number 5. Okay, let's do number 5 as a warm up. Number 5 basically is just going to be in the pre-state. It's assigned to what? Help me out. Well, basically just that, right? Remember, brackets is very important. Okay, it's going to be accounts dot twin. So now in this case, okay, I'm going to draw. Okay, so 5 is now going to point to the accounts dot twin, which means we're going to duplicate the array at the first level. So that it is going to point to this particular array, which is completely new. And then specifically, what about account objects? Do we create any new account objects? Yes. Shallow copy, remember, it's twin, right? So now in this case, remember it's twin, so we don't do it. So now it will simply point to the same account objects. Guys, make sense? Yes. 2 and 5. Good question. Okay, first of all, are we okay with 5? Okay, let's try 2. 2 over here, basically, if you look at, let me try to highlight it. You basically want to see what's being stored. For number 2, we are trying to store this guy here, which is simply accounts at position I. It's a basically reference copy to just this particular account objects. Okay? And now, for number 5, it's actually, you want to make a twin of the accounts and then point to it. Okay? Exactly. So now for 5, you can see for 5, it's actually pointing to this particular array rather than pointing to the accounts objects, right? It's different. Okay? That's good. So now, did we say 6 or 7? 7. I agree. I agree. Actually, 7 actually tells you something very important. First of all, there is a keyword in iPhone called current. Conceptually, nothing new. Current simply means this. Current will also be your friend sometimes, right? So now, thinking this way here. And since we say we are now assuming that we are talking about the bank class, so the current class is the bank, okay? So now, if we try to do, let me be consistent with the color. 7 over here. So if I say old current twin, so what am I trying to copy really? So 7 here, what would that be? 7 is assigned to what? Basically the whole thing, right? Okay, so if I'll say, yeah, I'll just copy, again, you're going to copy this expression verbatim, current dot twin. So now let's finish that for completeness. In order for me to draw that, let me just have some agreement. Let me just erase this, okay? So now, if I simply do twin, first of all, should I create a new bank objects? I should, right? Agree? Okay. So now, first of all, I should really create a new bank objects. And then that should have the ACCs, accounts. Now, should I create a new accounts array? Why? Shallow copy, exactly. That's why I didn't put deep twin here. It'd be too hard to draw. Right? But you definitely can use deep twin. Nothing wrong with that. Okay? So now, number 7 is simply going to point to this guy here, and that one is just going to point to the same array here. That's better? Okay, so now the main lesson over here, I didn't really give you any formal definition. First of all, I'm just trying to show you different possibilities of writing the old expression. You may want to use a combination of some brackets to say this is the one I want to store in the pre-states. And also you may have to use current sometimes. And sometimes you may want to use the twin versus deep twin. Okay? Any questions over here before we see the real example?
I'm sorry, I'm just a bit confused on current. So in your example, when you diagram, what exactly would current be referenced to?
So basically something I didn't really make it explicit. So the thing I'm assuming up to now was this. Basically, imagine that, here. All these ensure, every one of them, I'm assuming that I have a class called bank. And then, of course, there's a context from our discussion over here, class called bank. And then, and somewhere I have the ensure clause for one of the features, let's say. And then, in this case, it can be 1, can be 2, can be 3, can be up to 7. So now, when I refer to current, of course, I've talked about the context class over here. That's the current. So, which is exactly this object here. Yeah. I'm glad you asked. Yeah. Questions? Yeah, that's true. So I didn't really show you the deep copy in this case. You can think about the cases yourself. Yeah, so deep copy is just deep underscore twin. You can refer to the syntax. Yeah. For number 5, let's have a look. For number 5 over here. For number 5 over here, so basically we are making a shallow copy of the array. Agree? So that means for number 5 is now is simply just pointing to a new array. However, for example, at position I, we are still pointing to the same account objects. We're not really making any new account objects. Yep.
That's confusing. So what's the difference? The difference between the 3 and 5 is something similar to 1 and 2, except that I have to create a new.
Okay, so okay, let's be slow, otherwise nobody can follow. Okay, even myself. Okay, so now 3 and 5, right? 3 and 5. In the case of 3, what are we trying to copy? We're basically asking either to copy the shallow copy of the accounts itself. Agree? Because we're saying accounts I refer to account objects, make the shallow copy of that. That's number 3. For number 5, we are trying to make a shallow copy of the entire array. Okay, let me write it down. This will be shallow copy of accounts. And this guy here will be the shallow copy of array. Different. Yeah? Which number? Number 5? You mean the I here? Yeah, just some index. So maybe I want to modify, oh yeah, you will see the syntax like that a little bit later. So when you see the example, basically, let's say we want to modify only this particular account in the bank. Because you might have 100 accounts, I want to modify number 50, right?
So I understand that 5 copies the whole array, but does 3 only copy like that box I?
Exactly, exactly. So again, you're asking the difference between 3 and 5. Let me try to say it again. That could be the confusing point. So number 3, we are basically, let me use a different color. Number 3, we are trying to copy, basically, make a shallow copy of accounts at position I, which is make a shallow copy of this.
And
It still points to that particular object, right?
just a copy of that 5 box.
Exactly. Yeah, exactly true. And then for 5, we are trying to make a shallow copy of the array. In that case, we are really making the new array, and then let is still pointing to the object, right? Yeah. Yeah.
So number 6 in this case would simply be a copy where it would just have a reference to the
Oh,
class.
good question. So guys, what about number 6? What are we trying to copy here? Okay, number 6, you say shallow copy. I don't see twin over here, right? Be careful. It's a reference copy of what? Bank or array or account? Bank, yes. Since you ask, I'll put it down anyway. number 6, which is pink. Number 6 over here, right? We're only copying the current, right? So that means number 6 is going to be assigned to just the current. And remember, current is the bank class, right? So now that means 6 is just going to point to bank. Right? Are we okay? Wow, so many questions. Okay, yeah, can I take maybe 3 more? Okay, yeah. Please.
Can you only use the old keyword before something that's a member of current?
So say that again. I don't quite get your question. Say that again.
So for example, okay, so here let's say you want to make, you want to take the old value of current.account.
Okay.
Can you use old before something that's not a current, something that's part of a current, something that you can't put current dot before?
You know what? Let me think about this question here. That might take some example. Otherwise, if I just tell yes or no, everybody else will be confused. I'll think about it. Okay, good.
I'll come to you after the last one.
Sounds good to me. All right. Yes.
So in terms of efficiency,
Oh, sorry.
current like means a slower.
Oh, good question. Okay, guys, what about another possible exam question? Okay, another part, I like that. Okay, between 1 and 7, which one will be the cheapest to check at the runtime? Give me a number. Okay, 1 would be right because you just copy the integer, right? What will be the next one that's cheapest? Actually, you know what? This is not a good question, I realize, right? Because for many of the cases, you're just copying addresses. Okay, sorry, I will take it back. It will not be an exam question. Sorry. Yeah, I just realized it doesn't make sense, sorry. I'm thinking on my feet. Yeah.
Since the keyword old uses the assignment operation
Yeah.
to
To catch the value, yes.
cache the value and even the reference.
Uh-huh.
Well, cache the value, right? It's a reference.
Yeah, exactly, yeah.
Is there a way where we can maliciously change the state of the cache?
Yes. Okay. Your question was, so let's say we only write, for example, let's say we only wrote number 6. In that case, number 6 is only going to make a reference copy of the current. But now, let's say the implementation actually does some malicious change on the object itself. In that case, it's not going to be visible, right? Because if they are pointing to the same objects. But I would say, for you as the contract writer, you want to write it so that any malicious change that's going to be made, they will be caught. Okay, I would say save that question a little bit. We're going to see the complete example next time. Okay. Yes. How about can I say the final question? And then any other question related to this, I'll take it in the beginning of next time. You want to study that a little bit more. But my general feeling is you got it, right? Maybe?
The result of a old expression be void?
Can the result be the old expression be void? Yes, of course, depending on what you're trying to store, right? Maybe in this case, maybe you're simply trying to assign something that's void to something that's not void. In that case, old expression, yeah, of course. Okay, so now I'm glad you guys are happy with it, I hope, right? Hopefully that'll help your lab 1 as well, I hope. So now I want to do one more thing. That's a common mistake. I want you to look at, not here. I'll talk about a complete example in the beginning of Thursday, okay? But you want to think about this issue. I want to talk about the common mistake, and then I'll talk about bound diagram. That'll be for today, okay? So now what I want to do is, I want to, if you don't mind, I'm going to skip a little bit, okay? Okay, good. Before I show you I want to show you slides as well. Okay, I will simply go to this guy here. Okay, let's look at this class over here. I want to give you an idea based on what you have learned. Okay, now you can resolve this error by yourself as well. Okay, let's say we have this class. It's called linear container. Okay, just have an array A as the attributes, and then we have count, we have get. The get is simply just going to get element at index I. Okay, easy. And also we have a constructor. Okay, and now let's go on. Let's say I have a feature called updates, like a change at. Okay, now in the post condition over here, I'm trying to write the following. Okay, I'm saying across between 1 until the count. the size of the array. As, so this guy, so I say sj, so that should be j.item, right? You can say is j and just use j, either way, okay? And now I say j.item, now equal to I implies the old version of get j.item is the same as get j.item. Okay, something like that. I'm just trying to say, if the position is not the same, that means it has not been changed. Now, pretend you're the compiler. Pretend. You're not. Just pretend. Should this compile? Well, if you don't think that should compile, which part should you complain? Yeah, sure. I'm not sure if you noticed, I actually gave you a very obvious hints. No? Can you see the green one that's highlighted? That was the hints. Sure, okay. Anybody? Okay, now let me make it clear. Compiler will complain about the green part, saying J is unknown. I've seen, actually this question was posted yesterday, maybe from our section or the other section, either way. I was trying to explain that a little bit, right? So now we have more knowledge about the old keyword, okay? Let's be logical here. If you're the compiler, you look at the old expression over here. Let me try to help you a little bit. Okay, the same fragment of code over here, okay? So now what we will do is, so basically the old keyword here, tell me what expression is being applied, the old keyword. Oh no, I mean the old, yeah, sure, let me be more precise. The old expression over here, you can see that guy here is the old, right? Does that apply to this whole thing? Or does that apply to this one only? This one only, right? Okay, it's only, remember, it should follow about the value expression, right? So that means this O here is going to be applying to this only, first of all, okay? So now, question for you. If you are trying to, is it possible to actually store this particular value? Well, not just that it's a function call. Not just that. Tell me something. What's J here? What's J.item? Yeah, J.item only exists at this point. And you're trying to store that before the implementation. Basically, you're trying to refer to something that doesn't even exist. That's a contradiction here. That's first part, okay? Yeah, think about it. So now you are more concerned about how do I fix it, right? Remember I said brackets your friend. You want to really bracket only something that can be stored in the pre-states. Any suggestion? Well, apparently I cannot bracket this way, right? That's not going to help, right? I'm just trying to say, hopefully you wouldn't write it. Okay, don't try, right? Agent? Oh, no. You don't want to go for agent. No. You shouldn't even mention that. Yeah. Okay, any idea? So now, yeah?
Can we involve the A, which is an array?
You can, no, actually, you know what? You see, this is a feature call, right? We are calling the get, so nothing to do with the array. So now, something to help you, okay? I'll help you a little bit. Like in Java, every method call you're making has the implicit this. Remember, in Java, same as iPhone, same. This guy here is equivalent to old current dot get j.item. Just equivalent, but it will still give you the same compilation error. Now, how can we somehow turn that into something that we can store? Old current, I agree, but how can you force the compiler to give you the old current? Brackets, good, you listen to me. Brackets your friend. Old current dot. Now it will solve the issue. So yesterday, if you read my response in the post, when I suggested this, you may not actually see what's going on over here because it doesn't seem to be too different syntactically, but it does make a huge difference, right? Okay, any questions? Okay, so I would say we got about maybe 7 minutes or so. Okay, I want to do a little bit bond diagram for you. Okay, I will point out the most confusing part for the bond diagram for you, and then for the rest, maybe I will try to finish them throughout the course. Okay, but for the lab tomorrow, I'll be there. Maybe there'll be no demo, but I'll be there to help you with any issues you might have. I'll be there. Just make sure you show up. Okay. For the bond diagram, I want to go straight to the points about client-supplier relations. I think that's the one students are usually most confused about. Okay, you want to get it right. Okay, so now let me just go to design diagram. I'll go over other stuff maybe a little bit later in the course, so don't worry, I'm not skipping. Okay, what I would do is I will go to client-supplier right away. Oh, one more thing I want to point out before I talk about client-supplier. There are two words you have to know. One is called deferred, the other one is called effective. Deferred simply means abstract in Java, which means you got something that's unimplemented. When you got effective, that means something that's already implemented. Okay, just that. And then all the slides following this will just make sense. Okay, I'll go over that maybe on Thursday. Okay, but now I want to go straight to the points about client-supplier. So now I will simply go to client-supplier, and then we'll do some example together. Okay. Okay. Basically, client-supplier means two classes, one client, one supplier, for sure. And then, basically, every time when you're trying to declare a variable, and the variable might be a local variable, it might be an attribute, it might be a feature parameter, either way, then you have a client-supplier relations. So maybe in a single class, you may have more than 10 client-suppliers. Do you have to show all of them in the diagram? Not necessarily. You choose the ones you want to show. We trust your judgment, and then we'll assess that, right? Okay, so now what I want to give to you is some example. Now remember, every time when you're trying to draw a client-supply relation, there's something you have to put on above the arrow, which is a label. I'll show you exactly how you can see that. Okay, it's not difficult. I just need some concrete example to show you. Okay, so now let's see some example. Okay, so now I'm just going to go to that particular one. Sorry, let me skip a little bit. I think I meant to go to this one. Good. Let's look at some code here. Basically, you got to imagine that before you draw the diagram, you want to look at your code structure and decide what client-supply relations do I have, and then choose the ones you want to show in the diagram. Okay? So let me highlight to you. How many client-supply relation do we have? Okay? Remember, the principle is every variable declaration should be a client-supply relation. Okay? Want to suggest them to me? Anyone? Well, don't tell me the number. Just tell me which one. Data. I agree. That's one. That's an attribute, right? Any parameter? N? Any local? Yeah, exactly. Good. Okay, that's why I just showed them, right? So you got all the three possibilities over here. Even the local variable would be sometimes valuable to show in the design diagram. Okay, even local variable is supposed to be hidden. Okay. Okay, so now you can see that over here. Of course, utilities. That's something we talked about before. It simply got some search feature. Okay. Good. Anyway, so we got 1, we got 2, 3, and 4. We got 4 client suppliers. Let's say we want to show all of them. Okay. So now, how do we show them? That's the thing, right? Let me just give you one example. So data is a little bit more complicated because it involves an array, a collection. That's something I want to do later. Okay, later today. Let's try the this one here. So now, if you see, okay, I would say only focus. Let's do just the one for utilities, right? The one for NN and N would be something very similar. Okay, and then I'll talk about the data. Okay, that'll be it. First of all, you can see. Let's focus on this particular arrow. This one here. This one here. So now, according to the arrow over here, that's the origin. And that's the destination. The arrow direction is very important. Okay? So now tell me, according to the arrow, who is the client? Who is the supplier? Who's the clients? Database and supply is utilities, right? This makes sense back in the original code because in the context of database, I declare you so that I can use the service for utilities. So this guy here is a supplier. and this guy here is the clients. Okay, that's how you figure out the client and supplier. Okay, number one. Number two, once you draw the arrow, that's good. That's only half the story. You want to show the name of the supplier. In this case, you will simply show just you. Okay, that's a simple case. Don't forget the arrow and label. Okay. Okay, what we have seen, number one, how should the direction be from client to supplier? That's number one. Number two, what should be the name of the label? Follow the name of the variable, which is the supplier. Okay, now, another one, that's a tricky one. Okay. So now, if you look at data, okay, I'm just copying that over here, right? Data is of type array and also string. Now, how many suppliers do we have in this particular declaration? Two. Which two? Array and string, right? Okay, so now you have options. You may only show one arrow, in which case you decide to focus on array, or you decide to focus on string, or you actually draw two arrows. You got options over here. I will show you both options. Okay. I'll do that quickly. I know time's running up, but I just want to show you quickly. Okay. So now the first one. Okay. Again, database is the clients, and then let's say I want to show the string. In which case I'll say string is the supplier. Okay. In that case, first of all, I have to give the label data over here, and then for the plus, so we got plus versus star versus plus plus. Plus means effective. Star means deferred. Plus plus means redefined. It's set in the slide. You can refer to them. Okay. So now, how do we interpret this? We know that data should be an array of string. You can see the dot 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 over here. The dot 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 simply is referring to the string supplier I'm talking about. So that's why I don't have to write it out. Okay, that's one way to show it. Another way to show it, I may choose to focus on to say, now again, this is the client, and that's the supplier, in which case I can just say data. In that case, I can just need to spell out that's an array of string. So now I'm focusing on the array. Okay, so there are two ways to show collection type. Any questions quickly? Okay. Okay, good. So what I would do is I'll show up in the lab tomorrow, ask me questions, or office hour. On Thursday, we're going to finish the complete postconditions.